Hello, everyone. My name is Dave Beckberger. I'm a principal graph architect on the Neptune team here at AWS. And I'm here to talk to you today about how you can use Amazon Neptune to reduce the cost of running your openCypher applications. But before we jump into that, let's give a quick introduction on what graphs are, what graph databases are, and what Amazon Neptune is. First off, graphs and graph databases it's a type of technology that allows you to model data based on the relationships between data. I like to talk about graphs and graph databases as having elevated relationships and connections between data to kind of first-class citizens in ways that other technologies don't allow. And this allows you to build applications that explore the connections and patterns of connected data to really gain insights in ways that's not easily accessible in other database technologies. But this comes with some challenges with. First off, processing graphs is hard, and it's hard because the way you work with graphs and the way you process it really tends to have a very random data access to how you get to your information. So you really need to do these sort of generalized graph operations. You really need to work with a purpose-built technology to do that sort of processing. And this is where Amazon Neptune comes into play. Amazon Neptune is a fully managed, purpose-built graph database native to the cloud. It is a fully managed service, as I said. So AWS, we at AWS here take care of all the hardware management. We take care of managing your OS, your database server, and all the infrastructure and updates that come around with that. All it takes is a few clicks from either the management APIs, the consoles, or the SDK clients we have there, and you can have a cluster up and running in minutes. It's built to scale. And it's built to scale in a couple of different ways. It's a cluster-based architecture, so it can scale as a single writer and up to 15 read replicas. And recently, we announced 2 new features last year. We announced a serverless offering that automatically scales up and down, the size of the instance up and down based on the workload you put on the system. And we announced a global offering. The global offering allows you to have clusters that span regions, so you can really build that highly available architecture that we're all looking for. Neptune at its very core is really optimized to store billions of relationships between entities and to allow you to enable real-time navigation on those entities within milliseconds for many queries. One of the core kind of tenets we used when building Neptune was really basing it on open standards. So we support the 2 most common open standard graph models, that being RDF framework and the Local Property Graph framework. We also support the 3 most common open standard query languages. If you're working with property graph data, you can use either openCypher or Gremlin. And if you were using RDF, you can use Sparkle. We work with customers of all types across all different industries, but one of the common things we see is people that want to migrate their applications to Neptune. So why do they want to migrate their applications to Neptunes from other systems? Well, one of the most common reasons is they want to remove complexity, be it operational or developer complexity. They want to move to a fully managed service. It really helps simplify their lives, both during development as well as during production and ongoing maintenance. Another really common one, especially in today's climate, is cost optimization. Neptune is a pay-as-you-go service, so you're only paying for the resources you use at any specific time. So there's no upfront license cost. And this is even more important with our serverless offering, as that scales up and down automatically for you. Customers really appreciate the fact that we're based on open source standards and the common open source standards. So there's no vendor lock-in. You're not getting stuck with any or building your application on any proprietary language. We're based on those open standards. And we comply with 20 plus of the common standards out there, including some of the more commonly requested ones, such as SOC, FedRAMP, or HIPAA. As much as customers have told us they love graphs and they love Amazon Neptune, there's still some things they really, would love to be improved that we focused on over the last year. And that is really optimizing the developer experience and reducing the cost and making it easier for them to optimize the cost. For the optimized developer experience, last year we released openCypher. It's our newest query language on top of Neptune. And openCypher, we'll dive into some details here in a minute, but it works on any property graph data that you store inside Neptune today. The other common request was cost optimization, reducing the cost of this. And that's where we came out with Amazon Neptune Serverless. As I mentioned, Amazon Neptune Serverless is a serverless offering that scales based on the workload of your application. let's take a moment. Well, let's jump a little bit into what these are, and then we'll kind of show a quick demo of how these things work and what you can expect inside your account if you're using them. We'll start with what is openCypher. So if you're not familiar, openCypher is a widely adopted open query language for property graphs. openCypher provides an intuitive way to work with property graphs that really is, it's a declarative style syntax. It's clause-based, so it's very familiar for customers. And it works sort of like a pipelining language where you can stream together very simple sets of statements in ways that answer very complex questions. This has a lot of benefits. First off, it's flexible. With Amazon Neptune's implementation of openCypher, you can load your data once, and then you can query it either using our HTTP endpoint or client drivers. One of the unique aspects here is we actually, because it's property graph data, you can actually query it using openCypher or Gremlin. This allows easier migration of applications to do that, and allows development teams to choose the language that best suits the types of questions they're trying to answer. It's familiar. It provides a SQL-inspired syntax, but it's purpose-built for a graph database. If you look at that middle bullet point there, you'll see that that is what sort of openCypher looks like. It uses kind of motifs or ASCII art to express the types of patterns you want to look at here. In this case, we have a node. Anything inside of parentheses represents nodes. Anything inside square brackets represents edges. So in this case, we're able to say that Neptune loves openCypher. It's also fast. It's built on a purpose-built engine that really is built to efficiently scale the database resources for things such as CPUs, cores, memory, IO, all those sorts of things. So that's taking care of you as part of the fully managed service. And this pairs very well with our Amazon Neptune serverless offering. Our serverless offering is a first graph database that's built to automatically scale the capacity of the system up and down to really optimize the cost and performance of your application. It scales nearly instantly in the fraction of a second to meet workload demands, but it scales in very fine-grained increments. And this really helps eliminate a lot of the complexity and overhead that customers have had with trying to predict the capacity that they have on a variable or unpredictable workloads, or trying to figure out the number of provisioned IOPS, things like that they would have to buy ahead of time in order to meet their peak demands. And because it scales automatically, it really allows you to save a significant amount, up to 90% on your database costs, depending on your workload. So how do you manage serverless capacity? The fundamental unit of serverless capacity is a Neptune capacity unit. That's the measure we use for both scaling as well as billing. And a single NCU is roughly equivalent to 2 gigs of RAM and a proportional amount of CPU and network bandwidth. The user is allowed, basically when you create a cluster, as the user, you specify what you want for the min and max here. It goes from a single NCU all the way up to 128 NCUs. The minimum capacity basically determines the starting point for an instance, and the maximum capacity is basically a budgetary control. If you want to look what this behavior kind of looks like, if you will look at this, we have a server here. We're showing the capacity here. It's scaling all the way from 1 to 128. As the workload increases, we scale up. It looks like there was a little plateau here for a moment, and then additional workload was added, and we scaled up further. The same happens with scaling down. And if you kind of think this, over time, this ability to scale up and scale down really allows you to save a lot of cost versus trying to provision for the peak amount of work that you have. But this is sort of a complicated thing. If you look at these different colored lines here, these represent all the different decision-making processes that we're looking at behind the scenes in order to know when to scale up and scale down. These include memory, workload, CPU, network utilization, where you are in the min and max NCU, and those sorts of things. So it really it takes all these complicated things and makes it a very simple single number for you to be able to work with. So let's jump in and take a look, a quick look at what this looks like in practice. If I wanted to come in here, I've pre-set up a cluster here. If I wanted to add another, in this case, I actually have a single serverless writer, but let's say I wanted to go in here and I wanted to add an additional serverless reader. Let's see what it takes to do that. If you come in here, I can come and click on this actions button. I click add reader. When you come in here, you have the ability to select a couple of different things. You have the ability to select the DD instance class. One unique thing here is because your cluster, your Neptune cluster, can have up to 16 instances in it, you can actually mix and match both provisioned instances as well as serverless instances in there. If you wanted to add a serverless instance, as we do here, you select this instance types, that's DB serverless. You can come in here, you can select things like the availability zone, encryption keys, other sorts of settings to do that. But in this case, I'm just going to scroll down to the bottom and click create read replica. This will take approximately a couple of minutes. And while it's doing that, it actually will go out and create an instance for you. Let's take a look at what this what serverless instance looks like in operation. We come in here, we'll look, I did some work yesterday on this to set up a cluster and try a few things out. If you look at this, what we're looking at here is the orange represents the CPU utilization, so a proxy for what sort of workload we're putting on the system. The blue represents the number or the percentage of the total NCUs that are provisioned for this cluster that are being used. As you can see, if we zoom in a little bit further here, what you can start to see is as the CPU and the workload ramped up, so did the amount of NCUs, the capacity to be able to process that information happened. And as soon as the workload stopped, what you'll notice that it doesn't scale down immediately; it scales down in small increments. And this is so if you have a workload where you want to be able to you want to have the ability to have it still available if new queries come in. This allows you to do this. It'll scale down kind of incrementally in this stair-step sort of fashion. So that's sort of what serverless looks like. So maybe you're asking yourself, I'm interested in this. This looks very interesting to me. Where do I go to get started? Well, where I would suggest getting started is with our Neptune notebooks. Our Neptune notebooks is an IDE or a Jupyter-based IDE interface to be able to interact with your Neptune clusters to do things such as read queries, write queries, read the results, view them graphically, things of that nature. Within this application, what we have is a significant number of tutorials, sample applications, as well as, especially if you're new to the openCypher query language, we now actually have a set of openCypher tutorials that will walk you through learning this language and the intricacies of how that works. In this case, this is one of ours. We're able to see, there's a lot of information here. It tells you about how you can write queries, how you set up visualizations of these queries, the different types of syntactical things you want to be able to run, how to go about finding the nodes in your application, how to go about finding the edges in your application. With that, you can also come in here and write your queries. In this case, I'm writing a query here. This query is going to go out and find me all of these edges and be able to bring that up. You'll notice that took a moment there, but if I rerun this, because behind the scenes it scaled up the workload capacity, you'll see how quickly you were able to see that difference here, that scaling difference of the workload behind it. I'm also able to view this as a graph, so I can see the different parts and pieces here. So with that said, I wanted to kind of jump back in and do a quick little recap of what we have and where we are at. First off, graphs. Graphs are powerful things. Thousands of customers today use Amazon Neptune for common use cases for things like knowledge graphs, identity graphs, fraud graphs, security graphs, things like that. Neptune Serverless is a new tool, and it's a powerful tool that scales automatically, so you don't have to. You no longer have to figure out what size instance you need to run, how big your instances need to be, and you don't need to provision for that max peak performance. It will scale automatically as your queries actually go, as your queries and your workload demands. Combine this with openCypher and the simplicity and ease it is for customers to learn this language and developers to get proficient with it. It really simplifies the ability to create new applications, or if you have existing applications, to migrate those across. I'd like to say thank you. Once again, my name is David Beckberger, and feel free to reach out to me if you have any questions.